Rain.
R-E-I-N?
B-R-A-Y-D-O.
Oh, B-R-A-Y-D-O-N. Okay, B-R-A-Y-D-O-N. Did you... Brain. Okay, I think I can pronounce it. What happens if we put the pump in parallel? Do we get more pressure or we get more flow rate? B-R-A-Y-D-O-N. More rate. In parallel, we get more rate. In series, we get what? More pressure, right? It's not quite one-to-one. Okay, add that together. It's almost, but it's not quite one-to-one. It depends on pump curve. Okay, let's take a look at this. This is a head in feet and the pressure drop, volumetric flow rate in gallon per minute. If we have one pump, it looks like that. Two pumps, the curve shift up. Put it in series, so it may pump the same 2000, but the pressure is a lot more, okay, about twice. So when we put it in series. What about if we put it in parallel? If we have one pump, maybe at the pressure of 1200, we may get that much. If we put two pumps in parallel, we get about double the flow rate. Okay, put it in parallel. Yes?
This head pressure that you have here, that's got to be the pressure you're pumping against, right?
Head pressure, what is head pressure? Head is HD minus HS. Head pressure in the pump curve is this, HD minus HS. So that one that you see over there is the same as this one. So HD is a total discharge head. HS is a suction head. So it's a differential head that provided by the pump. Okay. If you want more head from the pump, put it in series. If you want more flow rate, put it in parallel. Okay. In addition to that, you want to do something more. Okay. Okay. First, let's talk about the advantage of the centrifugal pump. Centrifugal pump, inexpensive. Okay. No pulsating flow. Everything is just continuous. So that's the good thing of centrifugal pump. And if you select centrifugal pump in your design, you will say the good thing about it and why it fits to your application. Okay? Just say it. You just copy this. Okay? Or type it. They have few moving parts, therefore tend to have greater on-stream availability, low maintenance cost than positive displacement. PD pump costs more to fix. Okay? Require small space, less weight. So in relation to throughput. So if you are in a location that you don't want a big and heavy equipment like on a platform, you may need to use a centrifugal pump. This is also true for the compressor, right? You remember the input from Mr. Bulat that we use centrifugal compressor on the platform. There are no close clearance in the fluid stream, therefore they can handle liquid containing dirt, abrasive, large solid. Okay? So there is no metal-metal contact. A little bit of solid is okay, not too much. Because there is very little pressure drop, no small clearance between suction flange and impeller, they can operate at low suction pressure. Okay? They can use low suction pressure. This is good thing with this. So if you don't have much provide to the pump, centrifugal pump also work if you have low suction pressure. So this means it have less NPSHR, right? Net positive suction head required is less, so that it can operate with low suction pressure. Brandon, do you still remember NPSHR?
Sure.
Sure, okay. What's the full name for NPSH arm?
Say again. NPS.
NPSH arm. Net positive suction head required. This will be the exam too, okay? Memorize it. So disadvantage is not good with high viscosity liquid. Okay, corner. Corner. What do you think is not good for high viscosity fluid?
That positive suction head?
Why? Centrifugal pump is not good for high viscosity liquid.
Because it'll break.
Look at the screen, please.
Self-heating.
It causes self-heating, okay? So the equation that when we flow liquid, you think it may be just isothermal flow, no temperature change. That is true most of the time, but if fluid is viscous, what happens is it heat by itself by spinning liquid. Work convert to heat and it makes it hotter. Okay? If you need to control temperature, that may not be good. Only applicable, practical for achieving high pressure when there's a large flow rate. Okay, so this kind of pump kind of give you more volumetric flow rate than the pressure. If you want more pressure, you need PD. Okay. Lower maximum efficiencies compared to reciprocating pump. Okay. Efficiency is less because PD just move fluid directly, right? Less pressure compared to PD pump. PD have more pressure. Just that. Okay. Reynolds number fill unit thing. You can do that without any mistake. We talked about that already. And this is to tell you why it is important. On September 23rd, 1999, NASA lost the $125 million Mars Climate Orbiter spacecraft after that number of days journey to Mars. Miscalculation due to the use of image unit instead of metric unit. Okay. Apparently sent the craft slowly off course, 60 miles in all. So the problem with the unit conversion is important. How much important? $125 million. Okay, that much important. So it's good to know this, right? All right, we're almost done. The unit: horsepower to BTU per hour, horsepower to power force foot per second, kilowatt to BTU per hour is here. Energy BTU to joule, BTU to power force foot, G value in foot per second square. Pressure unit. Okay, one thing that I want you to be careful when you use pressure unit is this. When you use the detector most of the time is like, you may use the blue detector that's Rosemount. Okay, the name of the brand is Rosemount. Rosemount report the pressure at 68 Fahrenheit of water. So when they say 1 inch of water, it is that much, 1 to 148.64. Other brand may use other number. So inch of water is not universal. It changes a little bit, but it will matter when you try to measure something in the unit of inch of water, not psi. So that when it matters. Okay. So when you use a pressure transmitter, try to find out what is the definition of 1 inch of water. Different vendor or different brand have different number. Okay, area. So all these unit conversion factor will be given, but this thing not given. Okay, rho VD over mu, you need to know that by yourself. Good. You ready for exam? Say yes. Say yes. Brandon, you ready for exam?
Yeah.
You have to review a little bit, right? So that's your responsibility. A little bit more on the pump. And we are about done. So pump, you may not have seen every kind of pump. We will go through it quickly. Centrifugal pump look like that. You have seen it, right? We show you that. It has some impeller spinning inside. Okay, that's centrifugal pump. Lobe pump look like that, has some lobe. So this kind of pump is it PD or centrifugal? Jacob. PD, okay, very good. So this one is PD. We have screw. Okay, screw look like this. They're called progressive cavity pump. Okay. Basically it's a screw pump, right? Just this. Move the fluid in. So this one is PD. Okay. This one double screw. Okay, for multiphase flow. So it's a multiphase flow pump. Double screw, multiphase flow pump. Outside, okay, let's take a look at inside. So it works like that to pump fluid to the front. Okay, this is similar to the compressor. It just has 2 screws. So this one is for multiphase flow. It can be very big. You see this picture, very big. You see. Okay, next one. Jacob. Okay, let's take a look at this. This one they call boiler feed pump. Boiler feed pump inside look like that. Okay. Each of these yellow things is a blade that's spinning inside. Okay. You see, there are 1, 2, 3, 4, 5, 6, 7, 8. 8 impeller inside. Is this PD or centrifugal? Centrifugal, correct. So this is centrifugal put in series. Okay, many centrifugal put in series, and it will increase the pressure, not flow rate. Okay, centrifugal in series, and we have gear pump. Okay, move the fluid around. That's a gear pump. This one, another gear pump. Move the fluid around. It's a positive displacement type. That's gear pump. Sliding vane. Same as sliding vane compressor, but this time we use it to move liquid. So this is a positive displacement type. Okay, it go around and it's eccentric. Or is it? Yeah, it's not. It's a little bit off center. So this sliding vane, and I think you see this video already for the diaphragm pump. So diaphragm good with some solid. Remember that, right? And this ESP. ESP is many centrifugal pump put in series. Right? That's it. Yeah, many centrifugal pump put in series. So this is ESP. Lee, Chen, are you awake?
Yes.
Okay, very good. You have seen all this, and you know which one is positive displacement, which one is the centrifugal. There are 2 types, PD and centrifugal. So for centrifugal, we can have overhang pump, between bearing, vertically suspended pump. In the test, I don't test you if you know whether it's overhang or between bearing or vertical suspended. No, that's not the point. The point is you have seen it, okay? So the point is you come to class and look at the screen. So overhang API pump, it can look like that. So that is pump. So when you go to the field trip or you go to the plant and you see something like that, you know right away that it is a pump. Okay? When you see something big like that, it is a pump. So this is pump, OH model, or that is a pump. Between bearing, this kind of thing is between bearing. Okay? There are several models, and it can have multi-stage. Like this one, you have seen many inside. Right? All this overhang between bearing is not PD, it's centrifugal. Okay, that part you need to know. When you see this kind of pump, API something, like I show you this picture, you need to know, is it axially split or radially split? Is it PD or centrifugal? Just that. Or I show you this picture. I probably don't show you this picture because it's quite confusing. But this, obviously you see the impeller, right? Okay, this one we go through it already. Vertically suspended. Okay, you can have centrifugal pump in series. Or you can have the impeller at the end. So this one is, when you see this and you see internal part, you have to be able to tell me if it is PD or centrifugal. Generally, you know it, right? Is it PD or centrifugal? Come on, Jengli. Look at me, not somebody else. Not at the screen. Okay, correct. This is centrifugal type. Everything that you have seen here, centrifugal type have three subtypes like overhung between bearing and vertically suspended. This picture, centrifugal. Okay. API is 610. This is centrifugal. Okay. ANSI pump. So this tell you that the pump has some kind of, some pump has ANSI standard, some pump has API standard. So this kind of pump, centrifugal pump. Okay. Whether it's ANSI or API, when you see impeller inside, that's centrifugal pump. Okay. So this is ANSI pump. It tells you type of service, non-critical, what kind of service used for water, like charge or several things. It's just for your information, not for you to memorize. Okay. This is just for your information. ANSI pump can do less pressure, less temperature. API can do more. That is just for your information, not for you to memorize. But you know that information is here. Single stage API pump. So it can do hot oil pump, raw product pump, rich oil pump. So this is for your information, okay? Vertical inline pump. What I will ask you is not, okay, is this how many number of stage? It's kind of difficult to take a look, but if you see the blade, it's over there. So that is single stage. What you need to know for sure is whether it's centrifugal or PD. Okay. Next corner, what is your name, sir?
Chen.
Chen. Is it centrifugal or PD?
Centrifugal.
Okay, very good. This one also centrifugal, right? You have several impeller in the middle. This one may be difficult to tell because you don't see the internal part, but centrifugal pump, Sump, centrifugal pump. So this is for your information to check which one is for what. Centrifugal pump installation. Okay, this part I want you to pay attention. If you put two pumps in series, it does not double the discharge pressure. It increases, but not really double. Almost double, but not double. Okay. How do we? PD pump has nearly vertical line. So if you have two PD pump in series, will nearly double the flow rate. Okay. Two PD pump in series will nearly double flow rate. Two PD pump in parallel will nearly double the pressure. But I don't think it's a good idea to put two PD in series, especially if it is not continuous flow. Think about it. If you have PD that produce some kind of pulse like that, okay? If you have PD that produce some pulse like that, and both of your unit, they are not in phase, what happened? Oh, I put something else already, but another pump don't need something in yet. So what happened? It break, okay? But if you have continuous service like screw pump flow continuously, you may be able to put it in series. But most of the time, if you have PD pump, you don't need to put it in series anymore because it has high pressure already. Some caution when you put pump in series, or this one in parallel. Okay, each pump has isolation valve, so that one pump can run while other in service. So this means when you have two pumps, pump number 1, pump number 2, you need the valve before and after, so that if you don't use one, you close this valve, you can take it out and service, fix it, put it back. Okay. Next is suction line and isolation valve should be rated for discharge pressure. So the line on the suction and the valve that you use should be rated for discharge pressure. Okay, let's say you have centrifugal pump. Centrifugal pump, and we kind of accidentally close this part. Okay, we accidentally close this part and stop the pump. What happened to the pressure over here? It's connected, right? So the pressure on the suction line is the same as the discharge pressure even after you stop. So the pipe should be rated for discharge pressure. If you put it in parallel, you need a check valve. Okay, check valve need to be installed. Check valve, check valve, check valve. Next to Shane, what's your name, sir?
Jaden,
Jaden, what is check valve?
valve that checks the pressure, allows it to equalize.
Okay. Check valve have a plate in the middle. Okay. So that you have flow just in one direction. So it have something over there. When you have flow, the door is like a door or window open. But if you try to have a reverse flow, it doesn't work, it gets stuck. Okay? So when it allows flow only in one direction. So when you have flow to the right hand side, this lid open. But when you flow backward, there's no flow backward. This check valve prevents the backward flow. Okay? Have you seen check valve in the what's that? High bond filtrate, Jaden?
Yeah.
Yeah, there are many of them. Okay. From outside, we actually cannot tell unless you know how does it look like from outside. But you have several check valve. So we need check valve so that there's no flow backward. If both of your pump is not quite identical, then you may have some kind of flow backward, right? We don't want that. So put check valve. And we need vent and drain connection to remove any liquid inside the pump for maintenance. Okay. So we have to be able to drain all the liquid inside out. And if we install the pump in parallel, so install the throttling valve to control the flow rate without turn the pump on or off. You see this part. There's a pump that has a variable drive speed. Okay, variable speed drive, VFD, variable frequency drive. So when you have variable frequency drive, this means the control can say, okay, more frequency, pump faster, pump slower, pump faster, pump slower. That's okay. Some pump doesn't have variable frequency drive. It just pump at the same flow rate. Okay. Some pump just pump at the same flow rate. What do? Do you turn it off or turn it on? No. Okay. So we have a line to recycle. If you want to do flow less, you recycle more. If you want to flow more, you close the recycle valve. Okay? You don't want to turn it on and off. Install low and high pressure switch to sense if there's something wrong. If you do some mistake, close the valve, you don't want that, right? You want the system to tell you. If there's any blockage, then the alarm should sound. Okay, high pressure valve should, high pressure alarm should sound. And you need, what else? Low pressure switch point. You need set pressure relief valve. Okay, on both sides, I think, pressure relief valve, so that This is centrifugal pump. Centrifugal pump, you may not really need a pressure relief valve, but it's a good idea to have one so that it doesn't break apart. If you have a PD pump, you really need the pressure relief valve. Okay, because if you accidentally close the valve on the outlet and you turn on the pump, what do you think happened? Pipe break. Okay, so you have pressure relief valve so that it return back to the tank or something. So if you use PD, you need pressure relief valve. PD reciprocating pump advantage, so it's more efficiency, and pump speed doesn't depend on the head, right? If you have more pressure loss, it pumps the same flow rate. If you have, so it provides more pressure but less flow rate. So disadvantage: higher maintenance cost, more expensive, lower availability, and it don't do solid. Okay, reciprocating pump, but diaphragm pump, which is PD, can do solid, right? And it have pulsating flow, and it have higher NPSHR, net positive suction head required. So in the suction side, you have more pressure to feed liquid into the pump. And if you have pulsating flow, we have to have something to attenuate the pulse. Okay, so you may have acoustic, you may have some pipe vibration, you don't want that. Other positive displacement pump, those are the pump that you have seen. So when you see this kind of picture, it's not centrifugal, it's PD. Diaphragm can run die periodically without damage, handle the dirty liquid. Okay, that's diaphragm, inexpensive. Rotary pump, so can pump toxic liquid or radioactive waste, but you don't have a radioactive waste. Okay, but if you, in the case that you have radioactive waste in the nuclear plant, you have this kind of pump, positive displacement rotary pump. Multiphase pump, so multiphase pump used to pump multiphase flow, liquid and gas. That's for multiphase pump. It used to increase the well production rate, okay, lowering the back pressure on the well. And what else? It's damping the slug to the top facility. Is this one make sense to you? Dampen the slug. What is slug? Who did artificial lift before and have seen the multiphase flow lecture? Many of you, right? Okay, Joe, what is dampen the slug?
It's just gonna lessen the effect of
The slug flow. The slug body will just go away. So we can use to extending the subsea tie back. Okay, no need to build holes for every asset. So you can have one long pipeline, one long subsea pipeline. But if you think you cannot produce, so you have subsea multiphase pump. Okay, so it can pump with very long subsea tie back. Typically it's twin screw. Okay, and twin screw and helicoaxial. That's just for you to see. Okay, twin screw and this kind of pump used for subsea. Okay, reciprocating pump installation, you need NPSHA more than NPSHR. Okay, that's very obvious. Read it, okay? And installation, okay, like I said, you need, in addition to the same practice that you do for the centrifugal pump, this time you will need pressure relief valve. That is something that is important. It may or may not be in the exam, but that is an important thing to know. This time is different than the centrifugal pump. Centrifugal pump, if you accidentally close the valve for a while, you open it, no damage. Okay. But for PD pump, if you accidentally close the valve, it has damage. So we need pressure relief valve. So read this for yourself, okay? We need for both suction and discharge side. That's a pressure relief valve for both sides. You don't want to suck from dead end, right? It doesn't work. You will have implode. Okay, a little bit more. Last 6 minutes more on the how to control pulsating flow. If we have pulse, we can use vessel. We call surge vessel to reduce the pulse. So first type is liquid filled vessel. Use liquid compressibility itself to absorb the pulse. Liquid can compress a little bit, okay? So use a big vessel, absorb a little bit. But this one is good only for gaseous liquid. If your liquid doesn't have much gas, doesn't work, okay? Tank size is 10 times of the flow rate. Okay, let's take a look at other type. We have the one with bladder, the one with gas cushion, okay? So the way that it works for the one with bladder is, if you have pulse coming in, okay, let's say you have pulse, more flow rate coming in. This bladder filled with gas, right? So it kind of compress. So this volume reduce, but it have more pressure. So like have a balloon inside, when the pressure come, the balloon, you kind of squeeze the balloon and it have more pressure. Okay, when you flow out, the balloon expand. So if you have the bladder inside, it reduce the pulse. Okay, this one has moving part, but it works even though your oil is not like gaseous oil. So the one with bladder is good, but it requires some maintenance because it has moving part, right? Bladder has to inflate and back and forth. So bladder can get fatigued over time, and bladder has a temperature limit. So if you have a lot of pulse and you don't want maintenance and you have gaseous liquid, you can use just one tank. Okay. Another method is, so this one take a lot of space. That's a bad thing about it. Bladder, no need to monitor liquid level, prevent gas to dissolve to liquid. Okay. The one with gas cushion damper is much smaller than liquid filled dampener. So this one is liquid filled dampener is big. This kind of thing, a lot smaller. Okay, that's the difference. And one last type is tuned acoustical dampener. So this tuned acoustical dampener basically is have two tanks and connected with a pipe in the middle, just that. How much should be the pipe? How much should be the size of the tube? I don't know. And most of the time it's a trade secret, okay? They have some software to do the calculation to find out what kind of size of the pipe or what kind of size of the vessel to make it reduce the pulse. The working mechanism is based on acoustic calculation. Okay. It requires acoustic engineering calculation to design the system. Vessel and choke size adjust to specific resonance frequency. Allow the pressure pulsation from the pump at frequency above the resonance frequency to be attenuated significantly. So they adjust something so that when it has pulse coming in, the pulse go away. Okay. How do we do it? I don't know. You require acoustic engineer. It is expensive and it have high pressure drop. Okay. Because it's expensive because it requires some kind of calculation. Okay. Acoustic dampener look like this. Two vessels connected with that pipe. Alright, pipe vibration prevention. You still have 2 minutes left, right? We give you 10 minutes to walk between the classroom, okay? Let's do this one. It is desirable that the natural frequency of all pipe span is higher than the pump pulsation frequency. Okay, you don't want the natural frequency to be matched. Okay, pipe length where both ends are the same acoustically is not equal to wavelength of your frequency of the pumping frequency. The pipe length should be you don't want the resonance between pipe vibration and the pulse from the pump. Okay, that's what it is. And generally what you do, nothing bad happens if you put the pipe support spacing to be short. Not like support over here and very long distance support it another location. It may enough to support the weight, but you may have pipe vibrating. Come on, it's still 12:19. Okay, let's go. Okay, see you next time.